Welcome back to section 512. We're still talking about solving square root and absolute value type equations. So now for problem number 6, we can isolate the square root. So what we're going to do is we're going to get rid of the square root by squaring both sides. But when we square both sides, we have to be careful. We're squaring the entire left-hand side. So what we actually have is the square root of x plus 6 minus 2 times the square root of x plus 6 minus 2, and that equals. Now, when we square the square root of x minus 2, we just get x minus 2. On the left-hand side, we're multiplying those two binomials. The square root of x plus 2 times the square root of x plus 2. That's just the square root squared. So we're just going to get x plus 6. The square root of x plus 6 times negative 2 is negative 2 times the square root of x plus 6. Negative 2 times the square root of x plus 6, we get negative 2 square root of x plus 6. And then negative 2 times negative 2 is plus 4. When we combine our like terms on the left-hand side, we get x. 6 plus 4 is 10, so plus 10. Now the negative 2 square root of x plus 6 and the negative 2 square root of x plus 6, they're like terms. Negative 2 plus negative 2 is negative 4 times the square root of x plus 6, and that equals x minus 2. Now our goal is to isolate the square root now. So we're going to subtract x from both sides. And while we're at it, we'll subtract 10 from both sides. So we get negative 4 times the square root of x plus 6 equals, the x's cancel, negative 12. Divide both sides by negative 4. So we get the square root of x plus 6 equals 3. Now we have the square root isolated. We can square both sides again. When you square the square root, you get x plus 6 equals 3 squared, which is 9. Subtract 6 from both sides, x equals 3. And before we circle our answer, let's do a quick check to make sure it's a valid solution. You want to make sure you check for extraneous. So we always go back in the original. Square root of 3 plus 6 minus 2 equals the square root of 3 minus 2. 3 plus 6 is 9. So the square root of 9 minus 2 equals the square root of 1. The square root of 9 is 3. So 3 minus 2 equals, the square root of 1 is 1. 3 minus 2, 1 equals 1. That's a true statement. This solution, x equals 3, is a valid solution. Now for number 7, just like problem number 6, we're going to square both sides to get rid of the square root, at least one of them. So you get x plus 6 equals, write them out, 11 minus x minus 3 times the square root of 11 minus x minus 3. Multiply the binomials, the square root of 11 minus x times the square root of 11 minus x. The square roots cancel. 11 minus x. Square root of 11 minus x times negative 3 is negative 3 times the square root of 11 minus x. Distribute the negative 3, square root of 11 minus x. Negative 3 times negative 3 is plus 9. X plus 6 equals, when we combine, 11 plus 9 is 20. Minus x, and when we combine those, we get negative 6, the square root of 11 minus x. Now, isolate the square root again. So we're going to subtract 20 from both sides, and we're going to add x to both sides. So we get 2x minus 14 equals negative 6 times the square root of 11 minus x. Now, what we can do is, even though it's not isolated, we can still kind of work with this. we're going to square both sides. So when we square the 2x minus 14, off to the side, 2x minus 14, 2x minus 14. 4x squared minus 28x minus 28x plus 196. So we combine, that's 4x squared minus 56x plus 196. So that's what we have on the left-hand side. 4x squared minus 56x plus 196 equals. And now on the right-hand side, we're going to square both terms. Negative 6 squared is 36. And when we square the square root, we get times the 11 minus x. All right, so we'll distribute the 36. So 4x squared minus 56x plus 196 equals 36 times 11 is 396 minus 36x. It's a quadratic, get it equal to 0. Add 36x to both sides and subtract 396 from both sides. So that gives us 4x squared minus 20x minus 200 equals 0. Now we can factor out a 4, and that's going to make things a lot easier. 4 times the quantity of x squared minus 5x minus 50. So it's 4 times the quantity of, and we can factor this, x and x. To multiply to negative 50 and add the negative 5, we have a negative 10 and a positive 5. Now, set each factor equal to 0. 4 can never equal 0, so we don't have to worry about that. X minus 10 equals 0. X plus 5 equals 0. So our solutions, x equals 10 and x equals negative 5. Now we have to check to make sure that they work. So for the 10, the square root of 10 plus 6 equals the square root of 11 minus 10 minus 3. So it's the square root of 16. Square root of 1 minus 3. 4 equals 1 minus 3. 4 equals negative 2. That is not a true statement. The 10 doesn't work. Let's check the negative 5. Negative 5 plus 6 equals the square root of 11 minus negative 5 minus 3. So you get the square root of 1 equals the square root of 16 minus 3. 1 equals 4 minus 3. 1 equals 1. That is valid. Our only solution is x equals negative 5. Let's go to the next page. Problem number 8. Now, solving an absolute value equation, you want to isolate the absolute value bars. So we're going to add 5 to both sides. The absolute value of 9x minus 2 equals 7. To get rid of the absolute value bars, 2 equations. That 9x minus 2 could be a negative 7, or the 9x minus 2 could equal a positive 7. So we add 2 to both sides. 9x equals negative 5. Divide both sides by 9. X equals negative 5 ninths. Add 2 to both sides. 9x equals 9. Divide both sides by 9. X equals 1. So those are our 2 possible solutions. We could do a check. Absolute value of 9 times negative 5 ninths minus 2 minus 5 equals 2. 9 times negative 5 ninths, that's going to be a negative 5 minus 2. Absolute value of that, minus 5 equals 2. So that's the absolute value of negative 7 minus 5 equals 2. Absolute value of negative 7 is 7. Minus 5 equals 2. 2 equals 2. That's good. And then the 1. Absolute value of 9 times 1 minus 2 minus 5 equals 2. 9 times 1 is 9 minus 2. So it's the absolute value of 7 minus 5. 7 minus 5 equals 2. 2 equals 2. They are both valid. Excuse me. Okay, now for problem number 9. They're going to get a little bit more complicated because what happens here is we have a variable on the outside. So with that variable on the outside, it's going to change some things for us. Now, what could happen here is if we had a negative on the outside now, it's okay because we don't know what the variable's value is. But we still do the same thing. 2x plus 12 equals the negative 4x. 2x plus 12 equals a positive 4x. Subtract 2x from both sides. 12 equals negative 6x. Divide both sides by negative 6. X equals negative 2. Subtract 2x from both sides. 12 equals 2x. Divide both sides by 2. X equals 6. Now, it's very important that we check for extraneous here. Because with that variable, things kind of get a little weird. So now, absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. Negative 4 plus 12 is 8. Now, the absolute value of 8 is 8. So we get 8 equals negative 8. That's not a true statement. That negative 2 didn't work in this case. And then for the 6, 2 times 6 plus 12 equals 4 times 6. 2 times 6 is 12, so we get 12 plus 12, which is 24. And that equals 24. Absolute value of 24 is 24 equals 24. That's a valid solution. So the only solution that worked there was x equals 6. Problem number 10. Same thing. 4x plus 10 equals negative 6x. 4x plus 10 equals positive 6x. Subtract 4x from both sides. 10 equals negative 10x. Divide both sides by negative 10. X equals negative 1. 10 equals 2x. Divide both sides by 2. X equals 5. And as it was for the last one, it's important for us to check for extraneous. Absolute value of 4 times negative 1 plus 10 equals 6 times negative 1. 4 times negative 1 is negative 4. Negative 4 plus 10 is 6. So the absolute value of 6 equals negative 6. That didn't work. The negative 1 is extraneous. Now we check the 5. 4 times 5 plus 10 equals 6 times 5. 4 times 5 is 20. 20 plus 10 is 30. The absolute value of 30 equals 30. 30 equals 30 is valid. X equals 5 is a good solution. Okay, now problem number 11, the toughest problem on this page. We still want to isolate those absolute value bars. So we're going to add 9 to both sides. Now, what we get is the absolute value of 4x minus 1 equals 2x plus 9. Now, because there's two terms on that right-hand side, that's what makes this a little bit trickier. So to get rid of the absolute value bars, there are two equations. 4x minus 1 equals. Now, it's going to be the opposite, negative 1 times the quantity of 2x plus 9. And those grouping symbols are important. And also, 4x minus 1 equals the positive, or 2x plus 9. So knowing to put the parentheses there is the important part. So 4x minus 1 equals negative 2x minus 9. Add 2x to both sides. Add 1 to both sides. We get 6x equals negative 8. Divide both sides by 6. X equals negative 4/3. Subtract 2x from both sides. Add 1 to both sides. 2x equals 10. X equals 5. So there's our two possible solutions. So we want to make sure we check to see if they both work. So the 5 is a little bit easier. I'll check that one first. 4 times 5 minus 1, the absolute value of that, minus 9 equals 2 times 5. So now the absolute value of 4 times 5 is 20, minus 1 is 19. Absolute value of 19 minus 9 equals 10. So you get 19 minus 9 equals 10. 10 equals 10. That one's good. Now the trickier one, the negative 4/3. 4 times negative 4/3 minus 1 minus 9 equals 2 times negative 4/3. 4 times negative 4/3 is negative 16/3. Now minus 1 over 1. So if we get that common denominator, multiply by 3 over 3. So it's going to be minus 3/3 minus 9 equals 2 times negative 4/3 is negative 8/3. So we get the absolute value of negative 19/3 minus. Now I am already seeing that my denominator has to be a 3. So I'm going to multiply the 9 over 1 by 3 over 3, so we get minus 27/3 equals negative 8/3. Now, the absolute value of negative 19/3 is 19/3 minus 27/3 equals negative 8/3. So we get negative 8/3 equals negative 8/3, and that is valid. Both of those solutions, the positive and the negative, both worked in that case. Okay. So that is it for solving absolute value and other types of equations. I will see you in the next video.